let's look at fitting exponential models to data, okay? Exponential model, just to refresh your memory, will look like this. There'll be a base, exponent will be an x, maybe there's a multiplier on front, so there'd be a number in the a spot, a number in the b spot, and then your input's the exponent up here, and obviously the y. Okay, so let's look at this first example, okay? In 2007, a university study published this data on blood alcohol level, okay, and the relative risk of crashing. So what we're going to do is we're going to open up our TI-84 and we're going to insert the data, okay? I got a jump start on that already so that the video doesn't have to include me just entering data, but feel free to slow the video down. Feel free to pause and rewind so that you can write down the steps for entering the data. So I go to this site, or if you just Google free TI-84 calculator, you can come to this calculator and use it if you don't have one yourself. Okay, so when you turn it on, obviously, it will look like this, main screen. To get to the lists where you're going to enter in your data, you're going to go stat. And then we want this edit. So then enter on the edit. So let's hit enter. And then you'll have L1 list and an L2 list. I already entered L1 is the blood alcohol level. L2 is the risk of crashing, okay? So I already have that in there, okay? Next, let's go. I'm going to go second quit, so we're out of that after you get all your data entered, okay? And I'll come back over here. Feel free to pause and enter the data yourself. Then we want our calculator to tell us the line that fits the data best, or the curve rather in this case, okay? But let's take a picture, or rather get an image of what the data set looks like. So right here on the y equals button, it says stat plot. So that'll give us a scatter plot of this information. So I'm gonna go second, stat plot, and I see that it's turned off. So we're gonna go ahead and hit enter. And I'm going to turn it on, which is also an enter. Okay, so I don't have to keep scrolling up. I'm just going to do that. All right. So enter on. You can see the type that we're doing. L1 is the X's, L2 is the Y's, the type of dot that's going to show up. And then you can hit enter on graph. Right, come over here and push graph. Now, my graph is clearly way off, so my table needs some work. Our L1 was the X's, and it went from 0 to 0.21. So I'm going to go 0 for my X's to 0.3. Okay, now my Y values, this risk, it's on a percentage basis, so I'm going to take my Y's and I'm going to go from 0 to 100 for my 100%. And now I'm going to hit graph. There's my scatter plot. Very much looks exponential. Okay? So now that I have that in there, let's go. And you can quit out of that. It'll save that scatter plot. Okay? I want in my stat it to calculate, so second stat or list, just stat, I apologize, just stat. I want it to calculate, so I'm going to go over here to calculate. Janine, stat, over to calculate, there we go. Now look at the list that we have here of the things that we can calculate. I thought it looked really exponential, so I'm going to look for an exponential regression. There it is. Hit enter. Now, our calculator will calculate the line or the curve, in this case, that will fit that data the best. So L1 is the X's, L2 is the Y's. Don't have to worry about frequency, storing it. I choose to store it. You don't have to, but I do like to store it. So I come down here to store. I want whatever it calculates for the line to go into my y equals screen so that it will graph my curve. So I know I keep saying line, but I mean curve. All right, so I'm going to go vars going to go over to y vars, and I want to hit enter on function because I want the equation that this calculator comes up with to get stored in the y1 line. Okay, and I don't mean line, I mean curve. So I'm going to hit enter. It's going to now store it. And I'm just going to go down to calculate and hit enter. That's the a value for the number out front. There's the base, the b value for your equation. And then x obviously stays x and y stays y. Now, the nice thing about the storing that I did is that that equation went here in my y sub 1 spot, which means I can graph it here. Okay, so it graphed my curve, my regression line. All right, so we have it to data. Now it says, let's go to B here for the problem. After 6 drinks, a person weighing 160 pounds will have a blood alcohol level of about 0.16. How many times more likely is a person with this weight to crash if they drive after having a 6-pack of beer? Round to the nearest hundredth. Okay, so the blood alcohol level is 0.16. That, remember, was an x value. So we're going to go over here to our calculator. Okay, and I'm going to go, this calculate that's up here in blue, I'm going to go second, calculate. And I want to know a value. I want to know a y value, right? So I'm going to hit enter on value. And the x value that they were telling us, the blood alcohol level, is 0.16. Hit enter, and it found that point for us. So 26.35. That means that a person that has consumed and has a blood alcohol level of 0.16 is 26.35% more likely to have a crash than not. Okay, than if they hadn't drank the alcohol. So very informative, I think. Let's look at another model. This time let's look at one that is more logarithmic. Okay, and then just to refresh your memory, here's the kind of the format for the equation, for a natural log equation. Okay, so here's some data we're going to look at. I need to get that across over there. There we go. All right. Due to advances in medicine and high standards of living, life expectancy has been increasing in most developed countries since the 20th century. Okay, so we have a table of information here, and it's from the year 1900 and then life expectancy. And we can see it only goes up to 2010, so I'm sure there's newer data out there. But we're going to work with this table only. And this was just taken from our textbook, so to find information on this and where this data was taken from, feel free to use the note there. Okay, so what we're going to do for graphing purposes, and we're going to make a scatter plot. What we're going to do is we're going to call this year 1. Okay, so this will be our 1 in our table. 2, 3, because they're all 10 years apart, we can be consistent. 4, if they weren't, then we would have to come up with something else. Okay, 6, and so on and so forth, right? 7, 8, 9, 10, 11, and 12. Okay, so let's put this data in, and remember how to do that. We're going to go stat, and then we're going to edit. Okay, and again, I'm at this site for the free calculator use. Enter. To expedite our time, have already entered the years in that L1 column, so that would be our X's or our inputs. And then the expectant age is the Y column or the L2 column. Okay, so I have that in there already. I'm going to adjust my window. So when I graph it, how much do I want to see along the X-axis and how much do I want to see along the Y-axis? So window. I've already adjusted this as well. Since the X's are the year, I'm going to go 0 to 15. Y is the life expectancy. I went 40 to 90. Now, I could go maybe to 100 so we could see more. Maybe I'll do that. All right, so now let's hit graph, and our stat plot I've already turned on, but just in case I need to refresh your memory on that, you're gonna go second, and then right here, it's blue, it's stat plot. When you hit that, it'll say on or off here, okay? If it says off, you wanna turn it on. If it's on, great, leave it, okay? Now, just for the record, when you wanna come and turn it off later and not have data points on your graph, and want to just work with other mathematics, you'll turn it off the same way we turned it on. So coming to this screen and hitting enter. So mine's already on. So I'm going to hit graph now, and it plotted it. Okay. I'm seeing two things. Sure, it could be a logarithm graph, right? It could be. And that's what we're doing for this problem. So, okay, we'll do a logarithm graph. One could argue linear for this, because it looks pretty linear too. So lots of conversations about the reality of whether linear or logarithm is appropriate. I do kind of think logarithm is appropriate because we know that there is kind of this max age. Like, people don't just live forever, right? But we're kind of getting into outlier territory there anyway. So we'll stop, we'll look at this, and we're going to make a regression line with logarithms. So to refresh your memory on how to make a logarithm, or to get a logarithm regression, you're going to go back to stat, and you're going to go over to calculate, and you're going to look in the list to see if you can find the logarithm. I do see it. It's the number 9 in my list right there, and hit enter. I want to store it. So go down to store. I'm going to go vars over to y vars, hit enter, and I'm going to pick y sub 1 because then it's going to go into my y sub 1 equation, and it'll graph on my graph screen along with all the data points. So enter. It's going to store there, and then I want it to calculate, so we're going to hit enter and calculate. We know our a plus we know our b, which is the multiplier in front of the natural log of x. Okay. You will notice, since we stored it, it's going to be in this y equals screen, okay? And if we graph it, we will find the curve along with the scatter plot, okay? Now, let's look at here in the question, okay? So A was let x represent the time starting with 1, so we did that, okay? So they're 10-year increments. And then it says, let y represent the life expectancy. Use the logarithm regression, which we did, okay? So A is done. B, use the model to predict the average American life expectancy for the year 2030. So for the year 2030, well, if 2010 was year 12, 2020 is 13, and 2030, excuse my sloppy handwriting right now, I don't have my tablet laid down, is 14. So this is the x value, okay? I shouldn't write it like that. This is the x value, okay? What is the y value for that x? So we're going to come over here to our equation, okay? And this calculate, second, calculate, and we want value. So enter. X we said was 14, and hit enter. It found the point there for us, and it looks like for 14, which is the year 2030, the life expectancy is 79.10. So over 79 years. Okay. Time to look at a logistics model. Okay. To refresh your memory on logistics model, right here is the format for a logistics model. Okay. We have an equation for initial value, and we have, remember, like the maximum carrying capacity is the C value on top. We did that on a previous section. Okay, so we have some data here. This data is the year and the percent of Americans that had cellular service, okay? So what we're gonna do for we're gonna graph this, we're gonna put a scatter plot on our calculator with this data. We are gonna have 1995 be year 0, okay? And so on and so forth. So this will be year 0, 1, 2, yada, 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 okay? So then, this would be year 9. This is gonna be year 14, right? And this is year 17, okay? So we're gonna enter those into our scatter plot, or in our list so that we can do a scatter plot. So you're gonna come over to your calculator, stat, and then we're gonna go to edit. For the sake of time, I already put my data in there, and I aligned 1995 with 0, and 12.69% of Americans had cellular service at that time. Okay, so hopefully that makes sense. We've done a few of these now, so data is in there. My scatter plot, is it turned on? Second stat plot, I already have it on because of previous examples, but if yours is off, turn it on. When we're done doing examples, to turn yours back off, you're gonna come to this same screen, hit enter, and then get it turned off, okay? All right, so now let's talk about our window. For our window, remember our L1 column was the X's, and I go up to 17 for my X's, okay? So for my window, I decided to go 0 to 20, just to give us a little bit on each side. Well, actually just on the big side, I guess. Okay, and then the Y's. I think I'm gonna go higher. I know 100% would be the max, right? So I'm just gonna be a little dramatic and make it go higher. All right. Now, since my plot is on, I should be able to go graph and see my scatter plot, okay? It does look a little bit like a regression line and a logistics model regression. So we're gonna try to get our calculator to do a logistics regression. So to refresh your memory on that and how to get it to tell us that, we're gonna go stat, we're gonna go over to calculate, and we're looking at our options here. I don't see regression for logistics here yet, but let's see if there's more in our list. There is logistics right there. Okay. Yeah. Let's do a logistics model. So I'm gonna hit enter. X's are our L1s, Y's are our L2s. Frequency, I'm not gonna worry about that. I am gonna go to store it though. Vars, Y vars. I'm gonna store my Y sub 1 function. Okay. And then I'm gonna have it calculate. All right, so here's the format. It's telling us what our C is on top, what our A is, and what our B is. Now if we come here, C is up top, what our A is, and what our B is. So it's giving us all that data, okay? I stored it, so all that is also in my Y equals screen. And now if I go to graph, there it is. There's my logistics model. Okay, now let's answer some questions on it. First question, use it to find the logistics equations. And we already did that, so we have the logistic equation. B, use your model to calculate the percentage of Americans with cell service in the year 2013. Round to the nearest 1/10 of a percent. So if we use our model to do 2013, that would be looking at, so if we're doing 2013, let's go here, 2013, that in my graph would be number 18 for X. So let's do second, calculate, value, and this is when my X is going to be an 18, and then enter. 99.34. Oops. 99, seriously. 0.34 to the nearest tenths, 99.3%. Okay. All right, let's look at C. Discuss the value returned for the upper limit C. What does it tell you about the model? What would the limit value be if the model were exact? Okay, well, this might be an easy to answer part, but remember our equation, the C value, let's go back up here. It told us that the C value was 105.737. Well, the equation C value is 105.7%. This is too high, right? An exact equation would tell us what for the maximum? $100. Right. An exact model would have 100 because once you're over 100%, that's everybody, right? All right. That is it.